Hello everyone, I'm Hugo Swart, lead our XR, VR and AR business here at Qualcomm together with our Metaverse initiative. And today we have one more episode of Exploring the Metaverse. I'm looking forward to talk more about AI. And here with me today I have Moritz. He is a partner here with me in our XR journey. So Moritz, why don't you introduce yourself and tell a little bit more about your role here at Qualcomm?
Sure. So my name is Moritz. I'm part of the AI product management group at Qualcomm, and our team is responsible for scaling AI applications across all of our business units, which means taking our Qualcomm AI stack, which you can think of as a horizontal platform of AI software tools and capabilities, and bringing the stack into the different verticals so that OEMs and developers can build and optimize their AI models for the silicon they work on. So our team is in many ways in the cool and privileged position to see everything that is happening in AI across the company, from the smallest consumer devices you can think of, like wearables, to much bigger ones like cars. And my role on the team is to lead the commercialization of next generation AI technologies in XR, which is a very exciting field for machine learning, because XR use cases in many ways require both high performance, but also low power, because they run at the edge. And right. That creates all kinds of interesting challenges and puzzles for us to solve.
Yeah, that's right. I mean, I usually talk a lot about how XR and 5G were made for each other, but really XR and AI cannot be more important, right? So maybe can you tell a little bit more, you started, but how XR and AI work together? Why do we need AI with XR? Maybe a few use cases.
Sure. So I think a good way to answer this question and also to dive into the discussion is to start with the end user experience and work backwards from that, right? So I think at a very basic level, what we're trying to do in XR and in VR specifically is to render interactive digitally created content through a headset. And to do that, you not only need a high resolution display and a great rendering pipeline, you also need a device that is constantly gathering information about the world around you, scanning the room for obstacles, watching your hands, tracking your eye movements and facial features, and so on. So long story short, you need a ton of AI in just about any XR device that we ship, because all the perception functionality I just described is powered by machine learning. So in XR, you have significant power and thermal constraints when you deploy AI at the edge for a couple of reasons. Consumer XR devices need to be lightweight and affordable. So you ideally would want to price them in the hundreds of dollars, not thousands. Two, you're wearing the device on your face, so there's real physical limits to the temperature the device can produce. And three, XR is a sustained performance use case, which means your perception stack and all the AI workloads need to run for 20, 30, 40 minutes at a time. And that creates certain requirements that we need to support with XR devices.
That's great. You mentioned, a couple of areas of super important for XR, that AI enables us, perception and some of the rendering. But before we go deeper into that, we can't talk about AI these days without mentioning Gen AI, generative AI. So just a reminder of what is Gen AI and what do you expect will be the uses of Gen AI in XR?
Sure. So generative AI is basically a subclass of AI that is capable of generating new and realistic content, such as text, images, or even 3D content, which is something that becomes interesting for XR. The way you interact with these models is that you give it a text or an image as input, and then it generates something for you. The most prominent example of this is obviously ChatGPT, which has been making the news recently.
Right.
That is a transformer-based NLP model that is really quite remarkable in its capabilities, because it basically has the reading comprehension and the writing skills of a high schooler, and it even outperforms humans in some standardized tests these days. So it's a striking model in terms of its versatility, its intelligence, or just quite simply its ability to engage in a human-like conversation with us.
Yeah.
Another example in the visual domain is Stable Diffusion or Midjourney,
Yeah.
which are two text-to-image models that allow the user to generate high-quality images or even artwork with a text prompt, and the list goes on and on. I shall say, I mean, neither the concept nor the technologies behind generative AI are entirely new. I mean, they have been around for a couple of years now.
Yeah.
But we're really seeing a big acceleration in the past 6 to 12 months in the capabilities and also just the number of models that are coming out. And to me, this acceleration really marks an inflection point, because it's really the first time that AI is taken out of the hands of PhDs and put into the hands of like the broader population. So anyone can potentially become a creator now. So the other significant aspect is that it brings us a whole lot closer to human level reasoning capabilities. And then it also takes significant power to run them during inference, which means the big ones like ChatGPT or GPT-4, they can only really live in the cloud for now. To give you a feel for the size of these models, so ChatGPT has approximately 175 billion parameters, which means you need hundreds of gigabytes of memory just to store the weights.
Yeah.
So the question becomes like, what do we need to do to bring those models to the edge? I think the size of the model that we need to get down to is about 10 billion parameters, because that would still allow us to have like a decent quality of responses of the system, while also being able to fit them on the device. And we're actually making good progress towards that goal. So one example is at MWC this year, we presented a live demo of Stable Diffusion running inference directly on an Android phone. Without the need to call out to the cloud or to any of the heavy lifting. And we also have some other exciting demos in the pipeline that we're going to announce later this year. So stay tuned.
We know that AI is so important for XR, but can you tell us more? How is AI and XR used together?
So the way you access our hardware is through our Qualcomm AI stack, which is our unified software development platform for neural network inferencing. This stack supports all the popular frameworks such as TensorFlow or PyTorch, and it allows OEMs and developers to accelerate their workloads and access the actual silicon through both our AI runtime SDKs and through the Qualcomm AI Engine Direct, which is an AI library that delegates and deploys your model directly to the target processor.
So yeah, as we discuss, how AI and XR work together, can you explain what are the key building blocks, in AI that enable us it to be available for XR?
Sure. So every XR device on the market is equipped with a bunch of sensors and cameras that are capturing data about the environment. And what the device is then doing is it's basically constantly gathering information about the world around you. It's scanning the room for obstacles. It's watching your hands. It's tracking your eye movements. It's creating a facial mesh of your face. And so you need a ton of AI in just about any XR device because the perception functionality that we need to run is powered by machine learning that needs to run in concurrency. And you also need to really push the envelope in terms of the continuous use metrics, the thermal efficiency and the power consumption of the headset, and also the concurrencies that we have to enable. And that's what makes XR so interesting and challenging, because the compute requirements and the power budget are really at odds with each other.
Now that's great. I mean, as we plan, our platforms, our chips, processors for AR and VR, it's amazing how much AI we're putting into it for perception. But then you also mentioned the visual aspects, the rendering. Is AI also playing a role on that part?
Yeah, it is increasingly playing a role. So when it comes to rendering graphics on a VR headset, the way you do this traditionally is through a graphics rendering pipeline that runs on the GPU in your headset. What we're now seeing slowly as we're moving to these higher display resolutions and where the refresh rate also is increasing, we're seeing that it becomes increasingly challenging from a power perspective to render all the pixels on the GPU. And one way you can address like this problem to reduce the computational cost is an approach called super resolution, whereby you render the image at a lower resolution, and then you use a machine learning model to upscale the content by a factor of 2 or 4 so that it matches your display resolution.
And in addition, generative AI, I expect that we'll be able to create virtual environments, 3D objects. Is that something you expect as well?
When I think about generative AI use cases in XR, I get really excited about 2 long-term possibilities. One is being able to generate immersive 3D content and virtual worlds for XR.
Right.
The other is building AI-driven avatars and NPCs that then fill these worlds with life. I think we're making good progress on both fronts, and we'll see more progress over the next coming years. But we're already seeing some like the first gaming companies tip their toes into the water here. The interesting question becomes then, I mean, what is the roadmap beyond just generating textures? I think the next step will be systems that can generate 3D shapes of an object. So imagine, again, being able to generate a high-quality textured mesh of your dream car from scratch, just using conversational AI. I think that's something we'll see on gaming laptops in a couple of years, and then further down the road on headsets as well. Eventually, we'll be able to generate entire virtual rooms with virtual objects in them, just based on an image of the room that you showed the system. And so that will significantly reduce the barriers of entry for interior designers. And the end game to me will be something like John Carmack's vision of a generative AI system that can automatically create entire virtual worlds based on any video you give it. So imagine taking your favorite movie and generating a whole 3D virtual world from it, and then being able to live and play in this world. To be clear, I don't think something like this will be possible for a while, maybe for even 10 years or so. And it's certainly not possible to do that on a VR headset anytime soon, because that will take longer, but we'll eventually get there, I think. The key bottleneck will be finding the right training data to teach a neural network to generate 3D content, because the internet is full of high quality text, full of high quality images and video. So there's plenty of training material that ChatGPT and Stable Diffusion could use to solve these modalities. And what that means at the end is that some of your pixels are still rendered by a graphics pipeline, but some are also generated by an AI. And while that is currently mainly a use case for premium headsets, where, like, again, the display resolution is high, and we're beginning to see use cases that are pushing into photorealism, eventually, I would expect the share of AI-generated pixels to increase steadily until maybe one day the whole graphics pipeline is replaced by an AI.
Very cool. So now you talked about how much AI, both on the hardware and software, we're enabling through our platforms. But how do customers use it? And when I say customers, both OEM hardware manufacturers, but also developers. How do they have access to all this technology?
Sure. Let me start by quickly giving you an overview of the different processor options for AI in our chips, and then I'll tell you how OEMs and developers can work with it. So when you develop an AI model on our hardware, you can push the model to either CPU, to GPU, or to custom processors that are designed to handle AI workloads efficiently. The first and most important one is the Hexagon Tensor Processor, or HTP, which is our dedicated AI accelerator for neural networks that require high throughput and performance. The other one is called Sensing Hub, which is an ultra-efficient processor for smaller neural networks and applications like contextual awareness and all kinds of audio enhancements. Now, if you're an OEM or developer, the way you access these processors is through our Qualcomm AI stack, which is basically our unified software development stack for neural network inferencing. The stack supports all the popular frameworks. So if you work with TensorFlow or PyTorch, great, those integrate into the stack. And then if you're an OEM and a developer and you want to accelerate your workloads and access the silicon, you can work with one of our AI runtime SDKs or with Qualcomm AI Engine Direct, which is an AI library we've built that delegates and deploys your model directly to the target processors. So it gives you much more control over what's happening on the metal. And then these SDKs and AI libraries, they sit on top of a rich collection of compilers, math libraries, and other platform tools that help you accelerate neural networks at the edge. There's a bunch of stuff we have there. That's the AI stack. Another offering is our Qualcomm AI Studio, which we announced at Snapdragon Summit last year. AI Studio is a new work environment for developers to design, deploy, and profile their models in one single application. And that's a tool that basically brings together all the tools that I described before into an entirely new GUI, along with visualization tools that simplify the developer experience a little bit. So if you're interested in these tools, there's a great AI deep dive that we recorded at Snapdragon Summit last year that goes into all the details of our AI software offerings. Maybe we can link to that in the show notes for those interested in digging deeper.
So now, what if I'm a developer that I'm not as familiar with AI, but I want to build in XR, I'm using Snapdragon Spaces, what can I do?
Sure. So our vision for Snapdragon Spaces is to accelerate the development of 3D applications for both VR and AR. And part of this vision is to provide developers with our homegrown perception technologies that we have optimized for both performance and low power. And so as part of Spaces, if you're a developer, you receive a rich library of perception features that you can integrate into your app and call by API without really needing any background in AI.
Yeah.
And it includes all types of features that we touched on before. So you can integrate positional head tracking, hand tracking, spatial mapping and meshing, plane detection, object and image recognition, and so on and so forth.
So now, last question. We talked about AI as something in XR in general, applying both VR and AR. But let's talk a bit more VR and then AR, which there are differences, right? Given the amount of power that you can dissipate on a VR headset is larger. Maybe I can do more on the headset. In AR, you have a much more stringent thermal budget. So tell us more about how do you see AI for VR, AI for AR?
Sure. So in VR, as I mentioned, you have a lot of neural networks you have to run in concurrency.
Right.
The way that works, the way you would implement it on a VR headset is you first define a list of workloads you want to run concurrently. You then tune these workloads to reduce their latency and their power consumption on the target chipset. And then when you deploy the workloads, you schedule them at different frame rates that often depend on the use case. So some models you would want to update very often, like 60 or 90 times a second, while others you're fine running just 5 or 10 times per second. And your scheduling policy ensures that your models run exactly when they need to in order to create a compelling experience. Now in VR, there's a lot of IP both on the hardware and software side that we've been working on for quite some time to accelerate these types of concurrencies. Yep. And we'll be rolling out those features in the coming months. And they will, of course, also find their ways into our next custom XR chip for VR. AR, as you mentioned already, I think we've seen over the past few years that the technical needs of AR are diverging a little bit from those in VR. So most of the VR MR headsets in the market are standalone devices that are powered by a single SoC in the headset. For head-worn AR, the design challenge is to basically create eyewear similar to these that I'm currently wearing. So extremely lightweight, stylish, ultra low power. And as a result, we as Qualcomm and also the rest of the industry is moving to a multi-chip distributed processing stack rather than a single chip solution. And what that means is that your AR device can share computing workloads with a host device, such as a smartphone or a laptop. And the extra processing power that comes from this host device then enables you to create generally richer AI experiences, because the AR glasses can handle some workloads like positional tracking or basic computer vision, and then the smartphone or the compute pack can do all the heavy lifting in terms of running the app, doing graphics processing, but also running additional AI workloads.
Oh, that's super cool. Thanks so much, Moritz, to giving our audience a little bit more about why AI is so important for XR. It's great that at Qualcomm here, we're investing a lot in XR, we're investing a lot in AI, and these two together, I think, are going to create amazing experiences as we move. They are already today, but especially as we move into our roadmap. So thanks again, Moritz. Thanks for watching the Exploring the Metaverse show. If you want to watch another video or learn more about XR, click here. If you want to learn more about Snapdragon Spaces, click here.